We're going to work on some equations that are quadratic in form. And what this really means is we're going to do a substitution here with the variable. Or I should say, let's substitute with the term here. Now, we're going to let this x squared term be t. So we say, essentially, let t be x squared. And what that does for us over here is x to the fourth now will become t squared. So let's note that if we take x, or I should say t equal to x squared, and we square both sides here, raise the power 2, we'll end up with t squared equals x to the fourth power, because we just simply multiply the powers here for the variable x. So t squared becomes x to the fourth. Now your equation becomes 2t squared minus 7t plus 5 equal to 0, with the substitution that here t is equal to x squared. That's important, and we're going to use that. You see we have a nice quadratic equation here. Now, what you want to do here is you want to factor this equation and use the zero product rule to solve it. Now, in order to factor here, we have our a value, our b value, and our c value. We need to find two numbers whose product will be positive 10, because you recall we multiplied 2 with 5. That gave us the 10. And the sum here is going to be negative 7. It's this value here. So we have this x here. We need two numbers multiplied together is positive 10, but when added is negative 7. Now, because the number is positive as a product, positive 10, the two numbers the two numbers that'll work have to be both negative, because a negative times a negative is a positive, and that's the only way you get a sum to be that negative here. So we're going to try negative 5, negative 2. When we multiply them, it's positive 10, and we add them, sure enough, it's negative 7. So these are the numbers here. We're going to use these two numbers. Now, how we use them is to fill in the answer format with the negative 5 here and the negative 2 over here. So we have negative 5 and minus 2. But don't forget, we have to divide those answers by the a value here, which is going to be 2. So we divide by 2, divide by 2. On the left side, because we don't get a nice whole number, we're going to have to move this 2 up in that position so that we obtain here 2t minus 5 now. And because we get a nice whole number here, 2 over 2 is 1, we write this as t minus 1 is 0. So now we get to use the zero product rule. Now, zero product rule is whenever I have two terms multiplied together and they equal 0. What that means is either the first term was 0 or the second term is 0. You're going to add 5 to both sides here, and you'll add 1 to both sides here. You obtain 2t equal to 5, and you get t is 1. So when you divide both sides now by 2, we have t going to be 5/2. Okay, however, we're not done. this question was given to us in terms of x. We have to solve for x here. And so what you'll do now is go back and use this fact. We got to use the fact that t is really x squared. So we can write down the relationship that t is x squared here. We're going to replace this t and this t with the x squared now. And so what we end up getting here is x squared equals 5/2, and we get x squared equals 1. So at this point, we have two very special quadratics because the power here is 2. And we're going to use for both of these questions, we're going to use the square root formula. And by the square root formula, what that means is, since we have two of these equations here now, so we can put another t if you like, we have x going to be plus or minus the square root of 5/2. And here we have x going to be plus or minus the square root of 1. So at this point, we have to simplify here these radicals, and in this case we actually have to evaluate it, and that's not too hard to do since the square root of 1 is 1, and on the right side we have x will be plus or minus 1, and there's two solutions there. But on the left, we have to simplify the radical, and we know the square root of 5 over the square root of 2 is the square root of 5 divided by the square root of 2. So we can put this information over here. We can say square root of 5 over square root of 2, and now we multiply both the numerator and the denominator by the square root of 2 because we're going to rationalize this denominator. And as we multiply across here, here's what we're going to obtain. The square root of 10 over 2. And don't forget, that means x here is plus or minus 10 over that square root of 2. So your solutions are going to be positive 10 over the square root of 2, negative 10 over the square root of 2, positive 1, and negative 1. We now have solved this for x, which was the original question. Number 3, x to the 4th plus 2x squared minus 15 equals 0. We're going to substitute again. For this x squared term, we're going to call that t. So this is t. So we'll let t be x squared. What that now means is that this term here will actually be t squared. Because if you take t equal to x squared and you square both sides now, again, when you multiply powers, you end up with t squared going to be x to that 4th power. Okay, this gives us a nice quadratic with a different variable, the variable t. And this is what we're going to need to factor and use the zero product rule. So when you factor again, you want the product to be equal to negative 15 because there's a 1 here, a negative 15, so 1 times negative 15 is negative 15. and you want the sum again here to be positive 2. This is what the sum has to be. So when you put your product of negative 15, positive 2 here, we need two numbers multiplied together is negative 15, but when added is positive 2. Now, the only way you can multiply two numbers together and have it be negative is if one of the numbers was negative and one is positive. So I'm going to put in negative here and leave the other as a positive. So we'll try to take factors of that 15, and I'm going to use 5 and 3. So it looks like it might be 3 and 5, and let's double check. Negative 3 times 5 is negative 15. Negative 3 plus 5 is positive 2. So these are the answers here. This is what we'll use. Negative 15 and positive 2. So we'll have t here equals a 0. We'll use negative 3 and positive 5. Negative 3, positive 5. Bring out the t. We get t minus 3 is 0. T plus 5 is 0 by the zero product rule. Just remember, you have a first term here multiplied to a second term, and it equals 0. What that means is the first term was 0 or the second term was 0. So we can now solve these equations. Add 3, subtract 5. T here is positive 3, and t here is negative 5. Now, we're supposed to solve this for x. So we're now going to go back and use the relationship that t is x squared. So since t is x squared now, we can write that down. We're going to use t is x squared here for the t that you have here and here, which means this is now x squared and this is x squared. So you have two equations now. We have x squared here is 3. We have x squared here is negative 5. Now by the square root formula, and I'll say use the square root formula, we have the following. We could continue to change our paper there in two pieces. X will be plus or minus the square root of 3 by the square root formula. X will be plus or minus the square root of negative 5. Now you're done here because you can't simplify that radical. But on the right side here, we can simplify this radical. That will become the square root of negative 1 times 5, which is the square root of negative 1 times 5, and this is I times 5. Better known as 5i, so I can replace this with 5i. So x will be plus or minus 5i. So you notice we have four solutions here. Positive square root of 3, minus square root of 3, 5i, and minus 5i. These are the solutions. 5. 2x minus 1 to the 2/3 power equals x to the 1/3 power. Okay. looks like this question here snuck in. We're going to do the following here. We can't very easily do a substitution. So what I'm going to do here is, notice that this is 3 and this is 3. We're going to do what we did in the last homework assignment, which is raise both powers to the third power. It means raise both sides to the third power. What that'll do is I'll take this 3 and multiply it with my fraction 2/3. Take that 3, multiply it with a fraction 1/3. Which you end up now with will be 2x minus 1 squared equals x. Because if we look at the work here, 2/3 times 3, 3's cancel is 2, and 1/3 times 3 is 1. So this is why we have a 2 and a 1 power now. So on our left side here, we'll have to use FOIL. Because what you have is 2x minus 1 times 2x minus 1, and that equals x. So by FOIL we get 4x squared minus 4x plus 1 is x. This is a nice quadratic equation, which means if we're going to solve it, we have to have it equal to 0. And you end up here with 4x squared minus 5x plus 1 is 0. Okay, now we're going to have to factor this hopefully. Hopefully this is factorable. If it's not, we got to use the quadratic formula. So if we're going to factor this now, we have to identify the a, the b, and the c values because we need two numbers multiplied together whose product is 4, that's a times c here, and whose sum is negative 5, and that's just the b term. I should say the b value. So the product is 4, and your sum here is negative 5. We need two numbers. Now, if you're going to multiply two numbers together and the product is positive and the sum is negative, that can only mean both the numbers are negative. So we'll try negative 4 and negative 1. So negative 4 times negative 1 is positive 4, and negative 4 plus negative 1, sure enough, is negative 5. And let's be careful here. It looks like we're good. Okay, so this is x equal to 0. Again, we're going to use the negative 4, we're going to use the negative 1. And so when we use the zero product rule now, we have x minus 4 is 0. We have x minus 1 is 0. First term times the second term, and that equals 0. This means that first term is 0, or the second term is 0. So we're now ready to solve these equations here. We can add 4 to both sides. We add 1 to both sides. We end up here now with x is 4, x is positive 1. These are the solutions. And since we cube both sides here, these solutions are going to be our solutions. And so we're done. 4, 1. Now compare this question with the next one, which is number 7. Number 7, you have x to the 2/3 equals x to the 1/3. This is different. This is different than number 5 here. So even though we did all this work, let's get rid of this. Let's compare and contrast, because this is what they want us to notice, is that this question here we cannot do a substitution for. So a substitution cannot be done for 5. It can't be done for 7 here, because what we're going to do now is we're going to let x to the 1/3 power be our variable t. So we can say, let t be x to the 1/3 power. What that means is, if I square both sides now, since t is x to the 1/3, square the left side, square the right side, we get t squared is x to the 2/3 power. This is the t squared term. And now that means we have the equation here by a substitution that t squared equals t. So we have to solve for t here. Now, this is a nice equation to solve for, because again, you're looking at a quadratic power 2, so we need the left side, we need this to equal 0, so we're going to subtract 2 from both sides, and then we end up with a t squared minus t equals 0. Now, we want to factor this. We want to factor the left side. So we can factor out the t from both terms, and we'll get t times t minus 1 equals 0. And then again, by the zero product rule here, let's do this here. Let's change that. Factored out the t. Our zero product rule will say t is 0, our t minus 1 is 0. Meaning, first term is 0 times t minus 1, which is also 0. So I get the solution that t is 0 here. On the other side, we add 1, and now I get the solution that t is 1 over here. But let's recall what t really is. T is x to the 1/3 power. So since t is x to the 1/3 power, we're going to use that relationship. We're going to say t is x to the 1/3 power. What that means is this t and this t can be replaced with the x to the 1/3 power. So what that gives us is x to the 1/3 power equals 0, x to the 1/3 power equals 1. Now you can say, is this the cube root of x equal to 0, the cube root of x equal to 1? And the answer is yes, this is cube root. So we know how to solve these. All we have to do now is cube both sides. And our radical goes away. So we're left with just whatever is under this radical here, which is going to be what we need. X is 0 cubed, and x here is 1 cubed. So this means x is 0, or x is 1. These are the solutions, 0 and 1. So this question, you can do a substitution, essentially because they have the same base here. And like I said, these are actually specially chosen so that when you do the substitution, it will be a nice quadratic here, which is what we see. T squared equals t here. Number 9, x minus 1 raised to the 2/3 power plus x minus 1 raised to the 1/3 power minus 12 is 0. And as you can see, we got the x minus 1, x minus 1. So we're going to let now t be, again, this whole term. X minus 1 to the 1/3 power. That means if I square both sides here, second power, we multiply the powers together. This gives us t squared equal to x minus 1 to the 2/3 power, because 2 times 1/3 is 2/3. This is t squared, and this is t by that substitution. So we end up with t squared plus t minus 12 is 0. We're going to have to factor this. Now, at this point, hopefully you guys are very efficient at factoring. We need the product is negative 12. The sum will be positive 1. Negative 12 for a product. Positive 1 for a sum. Remember, these are A, B, and C values. This is what we're using. Okay, in case you forgot. Now we need two numbers multiplied together is negative 12, but when added is positive 1. Since the product is negative, one number is negative and the other one is positive. So I'll put the negative sign now. So at this point, we're going to try negative 4, positive 3, because when I multiply those two, I get a positive negative 12, and when I add, I don't get a positive 1, like we see here. So we're going to fix this. I'm going to use the opposite. So let's double check. Positive 4 times negative 3 is negative 12, and positive 4 plus negative 3 is positive 1. So these are the answers here. Okay. T is 0. Positive 4, negative 3. So again, by the zero product rule, first term times the second term equals 0. T plus 4 is 0, or t minus 3 is 0. So at this point, we're going to subtract 4 from both sides. We're going to add 3 to both sides. We get t is negative 4, and we get t is positive 3. But let's remember now here what t really is. T is this expression. It's the base of x minus 1 raised to the 1/3 power, or the cube root of x minus 1. So we're going to use this. We say t here equals x minus 1 to the 1/3 power. Now that t is the same as this t and this t. So we get to replace this portion with x minus 1 to the 1/3 power for both of them. So we get two equations now. X minus 1 to the 1/3 power equals negative 4. X minus 1 to the 1/3 power equals positive 3. This is the cube root of x minus 1 equal to negative 4. The cube root of x minus 1 is positive 3. Now, to solve these radical equations again, you guys already know you raise both sides to the index, which is 3 in this case. We're cubing both sides. By doing that, the radical goes away, And we have just what's left under that radical, which is x minus 1. So on the left, we get x minus 1, and that's negative 4 to the third power, which is negative 64. On the right, we get x minus 1, which is 3 to the third power, which is 27. We add 1 to both sides here, add 1 to both sides. You end up with x going to equal negative 63, x going to equal positive 28. So these are our solutions here. Negative 63, positive 28. So this is a quadratic form question where t is actually the base of x minus 1 to the 1/3 power here. And you can see that this is how we substitute here. Number 11. Six times x plus 2 to the 4th power minus 11 times x plus 2 squared equals negative 4. Again, you can see that we have a base here, x plus 2, but the power here is 2. So we're going to let t be x plus 2 squared. So this term is t squared. Sorry, this term is t. And by squaring both sides now, we get t squared is x plus 2 to the 4th. So this becomes t to the 4th. So we end up here with 6t to the 4th minus 11t is negative 4. Excuse me. This is going to be square both sides. I apologize, that's going to be t squared. Okay. There we go. 6t squared minus 11t equals negative 4. And you notice we get a nice quadratic equation again. Now when you solve quadratics, it has to equal 0, so we're going to add 4 to both sides here. You get 6t squared minus 11t plus 4 is 0. So this quadratic, hopefully we can factor. And let's try that out. Now, if we can't solve this by factoring, well, we simply use the quadratic formula. So we have the product here has to be, this is the a, b, and c value, is 24 because that's a times c here, 6 times 4. The sum has to be the b value here. So the product needs to be positive 24, and the sum has to be negative 11. So we need two numbers multiplied together is positive, but when added is negative. So let's think of the combinations here. Okay, 6, we got negative 11 plus 4. Okay, we're going to try negative 8 and negative 3. Negative 8 times negative 3 is positive 24, and negative 8 plus negative 3 is negative 11. So this is the pair. So we have t here equal to 0, negative 8, negative 3. And plug in negative 8 here, plug in negative 3 here. Now because our a value is 6, excuse me, we're going to divide both numbers by 6 here. Now, what we're supposed to get here is nice whole numbers, and we're not getting whole numbers, we're getting fractions. So we reduce our fractions in each case. 8/6 reduces to 4/3, and 3/6 reduces to 1/2. So you're going to take the 3, you're going to take the 2, you move them up here and here. We get 3t minus 4 equals 2t minus 1. And that'll be 0. So now by the zero product rule again, we have 3t minus 4 equals 0, 2t minus 1 equals 0. First term times the second term is 0. And what that means is either the first term was 0 or the second term was 0. We can add 4 to both sides here. We can add 1 to both sides here. We get 3t is 4. We get 2t is 1. We're going to divide both sides here now of the first equation by 3 and of the second equation by 2. So we get t here is 4/3. T here is 1/2. So we solved for t by making the right substitution. Let's go back. Remember what t really is. T is x plus 2 to the second power. T is x plus 2 to the second power. So we get x plus 2 squared will be 4/3. We get x plus 2 squared will be 1/2 because the t here is the same t that we have in both locations. So at this point here, we're going to get to use now the square root formula. So I'll abbreviate that here and say use square root formula. X plus 2 becomes plus or minus square root of 4/3. X plus 2 becomes plus or minus the square root of 1/2. Both these radicals need to be simplified. This radical and this radical. So square root of 4 over square root of 3. Rationalize the denominator. Square root of 4 actually will be 2 times the square root of 3 over 3. Because we multiply straight across, square root of 3 times square root of 3 gives us the value 3. And this 2, or the square root of 4, which is 2, is multiplied to the square root of 3. So we simplify that radical. Over here, we have the square root of 1 over the square root of 2. Same thing, rationalize the denominator. So in the denominator position again, the square root of 2 times the square root of 2 is just 2. And the square root of 1 is just 1. The numerator just has the square root of 2 here. So your answers are going to be now, as you see, x plus 2 becomes plus or minus 2 square root of 3 over 3. X plus 2 becomes plus or minus the square root of 2 over 2. What we'll do now here is we're going to subtract 2 from both sides. And I end up with x equal to negative 2 plus or minus 2 times the square root of 3 over 3. We get x is negative 2 plus or minus the square root of 2 over 2. These are our solutions. But if you look in back of the book, you see a solution set notation that'll look like this. that's because we have plus or minus. So here's the plus, here's the minus. We also have the other solution, negative 2 plus the square root of 2 over 2, negative 2 minus the square root of 2 over 2. Because again, plus or minus, we have plus, we have minus. We're done. X to the negative 2 plus 33x to the negative 1 minus 7 equals 0. So we're going to do a nice substitution again. Here, we're going to let t now be x to the minus 1 power. So what that means is we're going to square both sides here. Square the left, square the right, and you end up now with t squared being x to the minus 2 power because you take the negative 1 and you multiply it with 2. So this term is t squared. Well, this is my t term. So now when I go back and I plug in what t squared is and t, I get a nice quadratic equation. And hopefully we can solve this by factoring. And if we can't, we'll just use the quadratic formula. So remember, this is our a, our b, and our c here. So the product here has to equal negative 70. And the sum here is positive 33. 70, it's negative, sum is 33. So here's our product. So we need two numbers multiplied together is negative 70, and when added is positive 33. So one of the numbers has to be negative and the other is positive. So I'll put a negative sign here. We're going to try 35 and 2. Now be careful here, because it's true that negative 35 times positive 2 is negative 70, but when I add it, it's going to be positive 33. Excuse me, negative 33. That's not what we have. So we need to change our signs here. If we change our signs, this will work. So the numbers that will work here is positive 35 and negative 2, because again, when I multiply them together, the product is negative 70, but when I add them, the sum is 33. So, t, 35, negative 2. I'm going to plug this in here and plug this in here. Now remember here, go back and notice that a is 10. So I have to divide those numbers I found by 10. And hopefully you get a whole number. We don't, so we're just going to have to simplify our fractions here. Let's get t plus 5 goes into 35 7 times, and 5 goes into 10 twice. 2 goes into 2 once, and 2 goes into 10 5 times. Here's what we're going to do. We're going to use the 2, we're going to use the 5. Plug these numbers here. Let's get 2t plus 7, 5t minus 1, and this equals 0. So this term times the next term equals 0. So what that means is either 2 plus 7 is 0, or 5t minus 1 is 0 by the zero product rule. These are the terms here. This is 0, or the prior is 0. So by the zero product rule now, we can actually solve these equations. They're nice and linear. We end up here with 2t is -7 and 5t is +1. So when I divide both sides now by 2 and then 5 to get cancellation, we simply end up with the following. We end up with t going to equal -7/2 and t going to equal +1/5. So this is what we get for t. However, we have to go back and remember that t is really x to the minus first power. So t is x to the minus first power here. We're going to use that. This t and this t and this t are all the same. So we get x to the minus first power is -7/2. We get x to the minus first power is +1/5. And don't forget the meaning of x to the minus first power. It's 1 over x, which will equal -7/2. 1 over x is equal to 1/5. Now, when we cross multiply here, because we have what's called a proportion equal ratios, we'll get 2 is -7x. We get 5 here is x, which means x is 5. This one is solved. We just have to divide both sides now by -7. And as a final answer, we get -2/7 is x. Or we get x is -2/7. These are our solutions here. -2/7 and 5. And you're done. Number 15. X to the minus 2/3 power plus x to the minus 1/3 power minus 6 is 0. So if you notice again, we have the same base there, x and x. This is going to be our t now. So we're going to let this be t. So t will be x to the minus 1/3 power. And if that's the case, notice that when I square my t, raise it to the second power, I'll get t squared is x to the minus 2/3 power. To -1/3 gives us -2/3. So this is t squared. We get t squared plus t minus 6 is 0 now. This is a nice quadratic equation. And if you like your t here, or I should say the x, we need two numbers multiplied together, which will be -6, but when added is +1. So one's positive, one's negative. 3 times -2 is -6, and 3 plus -2 is +1. So these are the numbers. These are the numbers that we're going to use for t. T plus 3, t minus 2 is 0. This goes here, and that goes here. We're going to use the zero product rule. So this means the first term equals 0. or the second term equals 0. Okay, subtract 3 and add 2. So we get t is negative 3 and t is positive 2. But let's go back and remember again what t really is. T is really x to the minus 1/3 power. We're going to use that. So let's remember that this t is the same as this t and this t. So x to the negative 1/3 is negative 3. X to the negative 1/3 is positive 2. And recall the definition of what x to the negative 1/3 is. This is going to be 1 over x to the positive 1/3, which is negative 3. And 1 over x to the positive 1/3 is also 2. Now, x to the 1/3 down here in this denominator, we want to know what that definition is again. And to remind you that that's the cube root of x, right? And this is the index, cube root of x. So altogether, we have 1 over the cube root of x is negative 3. 1 over the cube root of x is positive 2. I'm going to write these things as fractions because now you have what's called a proportion equal ratios, and we get to now cross multiply. As we cross multiply, we get 1 equals negative 3 times the cube root of x, and we get 1 equals 2 times the cube root of x. We're almost there. We can divide both sides here by that negative 3 and divide both sides here by positive 2. So we get negative 1/3 is the cube root of x, and over here we get cancellation here. You get 1/2 is the cube root of x. So cube root of x is negative 1/3. The cube root of x here is 1/2. Okay. And again, how we get rid of this radical is by cubing both sides. And what we have left is whatever's under this radical. That's just an x. X is negative 1/3 cube. We get x is positive 1/2 cube. So perform your arithmetic here. Negative 1/3 times negative 1/3 times negative 1/3, 1/2 times 1/2 times 1/2. And when you multiply fractions, you multiply the numerators times the denominators, straight horizontally across. So negative times a negative times a negative is a negative. 3 times 3 times 3 is 27. So this is the first number. 1 times 1 times 1 is 1, and 2 times 2 times 2 is 8. So we get x here is negative 1 over 27. We get x here is positive 1/8. These are the solutions here. Negative 1 over 27, positive 1/8. Number 17. X minus the square root of x minus 12 is 0. Now here, our substitution is going to be for this t here. So we're going to let t be the square root of x. What we'll do now here is we'll square both sides. And we get t squared is the square root of x times the square root of x is just x. So what you'll see here is this will be my t squared term. So we end up with now t squared minus t minus 12 is 0. And what you're going to want to do here is you're going to want to factor. Now again, we need two numbers multiplied together whose product is negative 12 and whose sum is negative 1. So, one of them is positive, the other one's negative. Negative 4 times negative 3 is negative 12. Negative 4 plus 3 is negative 1. So you're going to get t here. This will be negative 4. This will be positive 3. Because these numbers here are what we are using again. Negative 4 goes here. The positive 3 goes here. So t minus 4 times t plus 3 is 0. We get t minus 4 is 0. We get t plus 3 is 0. You add 4 to both sides. We subtract 3 from both sides. And we end up now with t going to be positive 4 and t going to be here negative 3. So then the question is going to be, again, what is t? And t here is the square root of x. So we're going to say here, but t is the square root of x. This t is the same as this t, which is the same as that t. Which means this is the square root of x, and this is the square root of x. So we now have the square root of x is 4. The square root of x is negative 3. Now, if you're awake here, the one on the right is impossible. There's no real solution. But the one on the right, we can square both sides here, and we'll get x is 4 squared, which means x is 16. So remember, you can never have the square root and have the answer be negative, at least not in the case of working with real numbers. It can happen when you work with complex numbers, but that's another course. You got to take trig to answer that question. But here, we just use x is 16. And yes, you could go back and check this. It'll be fine. You did not square both sides or raise both sides to an even power like 4 here, at least originally. And so x is 16 should be fine, but go back and check if you like and say okay. If I plug in now a 16 here, 16, I get 16 minus the square root of 16 minus 12 is 0. Or 16 minus 4 minus 12 is 0. We get 16 minus 16 is 0. It certainly checks out. And you're done.